Okay, welcome to the deep dive. Today we're diving into something I think you'll find incredibly practical and, well, fascinating.
Hmm.
We've got this consultation record you shared. It's basically a snapshot of questions and answers from someone trying to navigate that tricky path of applying AI research.
Yeah, specifically in things like literature analysis and biotech data.
Exactly. And figuring out the next steps. Is it staying academic, moving to industry, or maybe even, launching a startup?
That's spot on. This source gives us a really great kind of unfiltered look at the real challenges someone faces trying to bridge that gap,
Yeah.
between interesting academic work and actually applying it.
Whether that's in a company or maybe going the entrepreneurial route.
Right. It's less about the specific AI models themselves and more about the strategic hurdles, the practical stuff.
And that's exactly why it's so useful, I think. It's full of very specific questions and the kind of direct, actionable advice you'd want at that kind of crossroads. So our mission here in this deep dive is to unpack this record for you. We want to pull out the most important nuggets of knowledge, the core problems they faced, the solutions suggested, so you can get a sense of the landscape and the path forward they were advised on.
Okay, let's get into it.
So the source kind of sets the stage, laying out the main areas this person was exploring.
Right.
We're talking AI for literature and data processing, specifically something called named entity recognition, thinking about startup potential, industry collaboration, market directions.
And really drilling down into data analysis, validation needs, that kind of thing.
Yeah, exactly. And those initial questions really zero in on the technical side, handling literature and data efficiently, accurately.
And what's interesting is that immediate focus on effectiveness.
Hmm.
It wasn't just, can AI do this?
Yeah.
But
How do we do it well?
precisely, how do you actually do named entity recognition effectively? That's the AI process, identifying key info like names, genes, places in text.
Right.
And they noted that existing general models weren't quite cutting it.
Falling short somehow.
Yeah. So they're asking, could specific tools help, like the OpenAI API maybe, or BioBERT, that's an AI model trained specifically on biomedical text? Would that give better accuracy for their specific needs?
Makes sense. And there is a very practical constraint too, right at the start.
Oh yeah, cost and scale. They needed to process a pretty small number of documents, like maybe in the tens,
Not thousands.
not thousands, exactly. And they didn't want to get locked into some super expensive enterprise-level subscription for that small volume.
Yeah, so they were looking for cheaper options.
They were actively searching for more cost-effective alternatives. And they even mentioned a specific tool, Perplexity, as possibility. It sounds like they're asking, is there a smarter, cheaper way for this specific limited task?
Which connects to that bigger challenge, right? Extracting genuinely useful information from all sorts of sources, academic papers, maybe company data.
Exactly. And that leads straight into the data analysis and validation questions.
Uh,
The record shows real concern about whether their current data set was even big enough.
the N count problem.
You got it. They mentioned that benchmark, often needing 500 or more documents or samples to get, statistically significant results for training or validation.
Right, so it's not just having data, but having enough of the right data.
Precisely. And they wanted guidance on choosing the right methodologies for analysis and, critically, how to build credibility. How do you prove your tech works to potential partners or investors?
How do you validate it?
Yeah. The source specifically brings up things like a proof of concept, a POC to show feasibility and value, or maybe pursuing patent applications.
Okay, so we've got the picture of the technical and data challenges they were facing. Let's pivot now to the advice given in the record. What were the suggestions for tackling those literature and data hurdles?
Well, the advice seemed quite pragmatic. For handling those small literature sets cost effectively, the suggestion was basically, explore simpler, more targeted AI tools, like that Perplexity example they brought up.
Steer clear of the big, expensive subscriptions if they're overkill.
Right. And to improve how they search and sort of build knowledge from their documents, the recommendation was to build a vector database.
Okay, a vector database. Remind us, what's the advantage there?
Think of it like organizing info by meaning, not just keywords. So it allows for much smarter semantic retrieval.
So you find things that are conceptually related, even without the exact same word.
Exactly. Really useful for building a knowledge base. And looking ahead, if they did have more literature later, the advice was to use AI for pre-screening.
Like a first pass filter.
Yeah. Filter out the most relevant documents before the human experts spend time on a deep dive review.
That sounds like smart workflow, using AI to help the experts, not replace them where it really matters.
Totally. And on the data analysis side, the advice really hammered home that point about scale.
The 500 plus number again?
Absolutely. They stressed needing that sufficiently large data set, at least 500 documents or samples, for the analysis to be statistically sound persuasive.
Got it.
They were also advised to focus their energy, develop their original core technology, emphasize the real innovation, not just small tweaks on stuff that's already out there.
Don't just iterate, innovate at the core.
Pretty much. And
Yeah.
for building that all-important credibility, the validation steps were key.
The PACE and patents?
Right. Do a proof of concept to show it works in practice, pursue patents to protect the IP, and, importantly, publish high-impact papers in good journals. Show the scientific rigor.
That package of advice really seems to lay out a clear path for building technical cred and showing value beyond just the lab bench.
Yeah, it's about translating that research capability into tangible, validated assets that others can recognize.
Okay, so moving beyond the tech details, this consultation also got into some much bigger strategic questions.
Big picture stuff.
Yeah,
Little
the
touch.
person was clearly wrestling with that fundamental decision. Should this research actually become a startup right now?
What's the feasibility? What are the challenges?
Yeah.
Especially thinking about how AI might speed up things like experiment design and biotech.
And they were asking about practical steps too, like upgrading lab tech. How do you get it to a level where it's attractive for, say, corporate collaboration or investment?
And a really specific question came up there. Would big companies actually fund academic teams just for equipment upgrades? That's a common struggle for labs.
It really is. And they were curious about newer tech too, like AIoT, AI, plus the Internet of Things and other digital tools. Could those boost lab performance, reproducibility?
Crucial for scaling research.
Definitely. And finally, guidance on direction, market, technology. How do you make sure the tech is specific enough to compete? How do you balance tech development with, a viable business model?
Right, making them work together.
Right.
And they even asked about specific industry players, mentioning Oracle and biomedicine as a potential opportunity.
So a lot of strategic ground covered there. What was the advice on that front?
Well, this is where it gets really interesting and maybe a bit counterintuitive for some. The recommendation in the source was actually pretty strongly against jumping straight into a startup.
Really? That kind of goes against the usual innovate and launch narrative you hear sometimes.
Yeah.
Why the caution?
The advice seemed focused on lowering risk. Instead of the high-wire act of an independent startup right away, the suggestion was to first explore joining something like a corporate sub-program. They used NVIDIA Inception as an example.
So like an incubator or partnership program within a larger company.
Exactly. The core idea was leverage academic corporate collaboration first, get access to funding, technical help, market insights that way.
And then think about going independent.
Yeah, defer the independent startup path until the tech is more mature, its value is clearer, probably proven through that collaboration.
So build through partnership first, spin out later, a phased approach.
That's the idea. And on funding, the source notes that for certain government grants, you'd likely need to lock down the team composition, especially confirming the PI, the principal investigator.
Makes sense. They need to know who's leading it.
Right. And for shorter-term funding needs, maybe midterm, looking at government resources or private incubators was suggested.
Okay. And what about those potential big partners, like the Oracle or NVIDIA examples?
The advice was, well, they might be interested. But again, that value proposition needs to be crystal clear first.
Proven value, back to the POC.
Back to the POC, ideally. The recommendation was start the relationship as a purely technical collaboration.
Just working together on the science first.
Exactly. Talking about setting up a separate company or getting major investment that should only come after the collaboration shows real promise and the corporation sees clear benefit.
Build trust and results first.
Seems to be the message. And to make the academic tech itself more appealing,
Focus.
the advice really stressed focusing on a single specific domain.
Like the example given.
Yeah, the example was focusing intensely on, say, heart model research, rather than trying to be a general-purpose tool for everything.
Yeah.
Be the best at one thing that matters to them.
Focusing to grab industry attention, showing you can solve their specific problem really, really well.
It definitely helps. And about getting corporate help for those equipment upgrades.
Yeah, the funding question.
The advice was pretty direct. Provide high-quality data through the collaboration. Show them your current setup, even if limited, can generate valuable, reliable data.
Ah, so proving the value of the data is the incentive for them to invest in the equipment that generates it.
That's often the most effective way. It's less about asking for a handout, more about demonstrating the ROI for them.
Right, makes sense.
And the source pointed out something important. Corporations usually prefer direct control over technology. They don't typically love outsourcing key stuff.
So academic groups need to offer something really unique.
Unique value or data or insights the company can't easily get internally. And the advice also included looking at existing business models they mentioned. CloudMile as an example.
To see how others integrate tech into corporate workflows.
Yeah, see how technology can actually create value within a business context. Learn from existing successes.
Wow, that's a really layered view of engaging with industry. It's definitely not just about having cool tech.
No, it's understanding the strategy, building trust, demonstrating value in terms that matter to the business.
It really shifts the conversation from look what our tech can do to here's how our tech solves your specific problem and here's why supporting it benefits you.
Precisely.
Okay, so let's try and synthesize all this. We've gone from the weeds of data processing like NER and vector databases all the way up to these big strategic choices about startups versus partnerships. Looking at the advice provided across the board in this consultation record, what are the main overarching themes that jump out?
Yeah, if you boil it all down, a few key themes really emerge from the advice in this source. First, there's a huge emphasis on strategic step-by-step validation.
Not just assuming the research is valuable.
Right. It's not enough for it to be scientifically cool. Its value has to be proven in tangible ways that potential partners or investors actually care about. That means patents, high-impact papers, real-world proof points.
Okay, validation is number one. What else?
Second, the advice keeps coming back to the value of focus. Sharpening the technology onto a specific, well-defined problem or domain, that seems crucial for increasing its attractiveness, especially to industry.
Be specific, be competitive.
Exactly. And maybe the most significant theme is the preference for a phased approach to industry engagement.
The collaboration before startup idea.
Yes. Start with collaboration. Build maturity, prove the value, establish relationships first, rather than rushing into an independent company. It really underscores the need to understand and align with what industry typically wants.
Which seems to be things like control, clear demonstrated value, and high-quality data.
That sums it up pretty well. Aligning with those industry preferences seems key, according to this record.
Well, this deep dive into the consultation record has certainly given us, and hopefully you, a clear view of the journey someone might take. Moving from promising AI research towards real-world impact, tackling data issues, making those tough calls about commercialization or collaboration.
It really does map out a pragmatic path,
Yeah,
moving out of the purely academic space.
absolutely. And maybe here's a final thought for you, the listener, to chew on based on all this. Reflect on that tension we saw in the source, the tension between, the open-ended nature of pure academic research and the very focused, validated, strategic steps needed to actually transition that research towards real-world use and industry value. What stands out to you most about the practical advice given here for bridging that specific gap?
Yeah, that's a good question to ponder.
Indeed. Thanks for joining us for this deep dive. We'll see you next time.